One question which people sometimes have is why is it that a class can only extend one other class, but it can implement loads of interfaces, and interfaces can extend a load of interfaces as well. And the question is, why is that? And this really boils down to why is multiple inheritance a problem, because that's really what you're trying to do if you bypass this. So let's take a look at this example here, which you can't do in Java, of course. But supposing we had this class here, professional musician, which is a subclass of both of these two classes, worker and musician, and person is at the top of the tree there. Okay. Now, supposing person contains the field age, for example, and the field name. Now, it's likely that there should really only be one age in professional musician. It doesn't matter if they're viewed as a worker or musician, there should just be one age. But if you look at something like name, then it's likely that the musician's name would refer to stage name, and the worker's name should be probably the real name. So you'd have professional musician. If viewed as a musician, it should be something like Elton John. Viewed as a worker, it should be Reginald Dwight, I think his real name is. So you didn't think it was Elton John, did you? So that's the problem. Sometimes you want fields combined, and sometimes you want to treat them separately, and it's really problem dependent. There's no one choice is going to be correct. What sometimes happens is that this person class gets kind of expanded, so it sits behind worker and musician. And this is all the sort of problems that you get in C++. Now there's another problem as well, and this is all to do with overriding. Now if a person's got a method work, and both worker and musician override it with their own version, what happens if we have some variable of type person, for example, and set it to refer to an object of type professional musician, and you can certainly do that because it's a subclass, and then you call p.work. Well, either that one or that one gets run in. That again is a problem. Now all these problems have got solutions, but there's none of them are very elegant. And really for that sort of reason, people in C++ tend to avoid multiple inheritance, because it can be a real problem, especially if you're casting from one type to another, as you can do in C++. It can leave pointers going all over the place and cause unexpected results. So C++ programs tend to avoid it. Now in Java, multiple inheritance of interfaces is never ever a problem, because they don't contain any code, and they don't contain any fields which hold anything other than constants, so they're just treated as complete constants. And if you've got two of the same name, then the compiler will just say it's ambiguous, and you have to resolve it. So multiple inheritance of interfaces never a problem in Java, and is quite encouraged, and is used a lot, of course. Okay then, right, suppose we've got two methods, and they've got the same name, and they're from different interfaces, and you inherit both interfaces. Well, that may or may not be okay, depending on the signature and probably return type and any throws clause as well. In fact, a proper understanding of this requires that you know a lot about overloading, a subject called overloading, and that's really covered in the next lecture, but probably by the end of this one you could probably work it out, so I won't say any more about that at the moment. Right then, And now here's one thing that's quite important. It's very important to keep instance methods separate from static methods in your head, as it were, because an instance method can't be overridden with a static method, and nor can you hide a static method with an instance method. They're basically just completely separate. And if you try and do either of those things, you'll get a compiler error. And just point out here that sometimes the Java specification uses the word override for static methods, and sometimes it uses the word hide. I've been careful and kept to hide wherever I remember, because really it is hiding and not overriding. Okay. Alright, then supposing you've got two fields and they've got the same name and they're in different interfaces and you inherit from both of them. Well, that in fact is quite okay. But if you use the field though, you've got to specify which interface it comes from, or the compiler will complain that it's ambiguous. So here's an example. Here's interface A and B, and they've all got, both of them got constant I in both of them, and there's also a constant J, which is I plus 8. Right, and you'll notice that these are static final constants. And with interfaces you have to specify an initializer when you define it. So there's got to be an equal sign there. You can't use something like a static initializer or something like that in an interface. And so this is about as radical as you can get, because what it's doing is constructing a random integer basically. It says new for a random number generator, and random, if you look at that, class for that is got next int, which just gets a random integer. Right, here we go. If we got another class that implements both of them, and a procedure, a method rather, like this in it, what it prints out is a equals and whatever that a const I is, that one, and then it prints out j equals and whatever that one is. And here I'm just pointing out that you've got to specify that a. You can't just say const I, because const I would be ambiguous. So you've got to do a dot. That's all you've got to do. It's fairly simple.